Okay, so this is assuming that you've already created your Tinkercad account. We're going to come into Tinkercad and we're going to go ahead and say new. And when you do, I already did this, but my son apparently had to get up and go to the restroom. So we're restarting it. So I clicked in here and I changed the name to Activity 124 Sequential Logic Breadboarding. And let's just go ahead and start by adding in some components. So first thing we're going to do is come up to Component Basic and go All. Okay, so now we have all the possible things that we might need. So I'm going to go ahead and jump my wires real quick. So this is what we're going to go ahead and jump, 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 and I'm just clicking every time I do that. I'm going to type in, let's see, that's red for positive, so I'm going to go type in 2, and then I'm going to type in, or click, 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 click. It's going to be 1 for black, and I literally am typing in 1. So what I'm going to do, just because I want it to look fancy, I'm going to pull it down until I get those lines. The same over here. This is not something you have to do, but this is a good skill to learn. So now we have that there. And let's go ahead and put in, first thing we need is a push button. So I'm going to type it in, push button. I'm going to go ahead and I'm going to line it up here. Okay, so now we have that. I'm going to tie in my positives, type in 2, and now we're going to type in, next thing we need is our actual D flip-flop. Again, what we're making here is this flip-flop. Okay, so we're gonna automatically tie the preset and the clear into 1 high for both of those. So let's go ahead and, we can't just put in 1 7474. We have to put in an actual chip for 7474. So let's go ahead and put that in. So we're going to type in 74. Excuse me, I don't have 74, maybe 74, 74. I'm typing that in on my keyboard, and that's going to be the dual flip-flop. I want to line it up with the beginning of that one, so 13. Now, if we start to look at the pin out for this, this is pin 1 through pin 7. This is 8 through pin 14. Okay, so we want to tie power in to power and ground into ground. I'm going to change that to 1 for black. Now, if we remember here, okay, clear and preset are always tied into high if we're looking at how we want to not worry about preset and clear affecting the actual D flip-flop. So what we're going to do is we're going to tie input 1, excuse me, preset 1 into high, change that to 2. We want to find set 1. Okay, so that's set 1 into high as well. Now in our flip-flop, we have Q naught tying into input data 1. So here in this, that's technically input 1. So what I want to do is I want to tie input 1 to, here they call it inverted output 1. So input to there. And that is literally the same thing as tying this, that junction, up into this. Okay, this is how you would actually breadboard this. Okay, the next thing that we need to do, and this is again just looking at the function of this preset, we need to go ahead and tie clock. We're going to use this clicker for clock. I'm just going to change this to some random color. Let's go turquoise, sure, why not? Okay, so when power comes in, we click this, it's going to activate our clock, and that's going to set everything for us. All right, so we have data going to Q naught. And then the next thing that we need is Q and Q naught coming up to some sort of probe, in this case an LED. So let's go over to our types and let's just type in LED. Just kidding, LED. I want to put them all the way over here because we are going to use these for other things later. I don't know. The color doesn't matter, but let's change it to something fun. So we need one and we need another one for Q and Q naught. Sure, orange and blue. Alright, so this is going to be our output. Excuse me. The output is going to go ahead and get tied into. So let's go ahead, pull this over just a little bit. Remember, we want to go into the anode here. So anode. Now I typed that extra slot in so I can add a pretty little joint there. So it kind of bends up nicely into that. And I need, I'm so sorry, I put this in the wrong one. Yeah, it doesn't necessarily matter for this, but let's just do it right first time. So that now we have output. So let's go ahead and tie this guy in. I'm just going to slap it down there and then pull it up. And if that's not perfectly square, let's go ahead and just tidy that up. So now we have lines up and down. Let's just change the color of these wires. That way it makes it easier for us to see in case we need to go in and change or modify something later on down the road. Sorry, we're getting a little bit of feedback there. Purple, sure, why not? Or not? Doesn't look like purple to me. There we go. Okay. I'm going to just tidy that up. Tidy that up. Alright, that looks good. Now remember, this is going into the anode. We still need to tie this back down into the cathode here. So for this, let's go ahead and add in a LED, or excuse me, a resistor. Okay, when that happens. Resistor. For this, we're going to actually just tie it directly from the cathode of each of these. Okay, into ground. And that makes me notice something over here. My bad. This should be tied into our ground. That's a silly error to do. So let's go ahead and put that in, and let's put another one in. And we're chasing that down. Again, you can jump that. You can use that as your jumper wire. So resistance is coming at 1 kilo ohms. We don't want that. We just want a buffer. So a buffer typically is about 220 ohms. So red 2, brown is 0. Let's do the same. 2, 0. Okay. Now let's check everything real quick. Okay, so we've got clock coming in, power and ground. We've got data tying into our invert output. Real quick, we've got invert output going to our Q naught. We've got output going into our Q. We've got everything going in. The only thing we're missing is a wire here. Type in 1. Again, we got to bridge that gap. Now the last thing that we need is going to be a power supply. And I'm going to go and place that there. Zoom out just a touch. Use my scroll wheel to zoom out. And we're going to go ahead and drop. Oops. Sorry, the wrong place there. Let's go ahead and hit 2 on my keyboard. And then 1. I'm going to click left on my keyboard once. Nope. Right? Nope. Okay. Either way, it doesn't matter. And now let's check our simulation. So everything is set up properly. So when we come up, both of these two LEDs should be lined up. Again, just to make sure we have this is Q. This is Q not, or not Q, either way you want to think about it. Okay, so when we pull this up, both of these will be 1 because that's the initial state of this. And then once we cycle through by clicking on our tab, we should see this change to Q. And then every time we cycle through, Q will invert to Q naught, and Q to Q naught, Q naught to Q, vice versa. So we see those are eliminated. So let's cycle in once, and sorry, there was a little error there. So when I click on it, now we go to Q, and the Q naught is eliminated, and again, the flip-flop is here. When we click on this, it sends the data in to D1, which sends it to Q naught. Now that it's in Q naught, now it can send the signal up to that LED. And again, when I click off of it, it flips the circuit, so now there's no longer a data into data, or excuse me, a high into data. So it's not going to send an invert out to Q naught, and it flips back to Q1 or Q. And again, every time we do this, it's going to flip that signal. Q, Q naught, Q naught, Q, Q naught, Q, Q naught. And that's how that goes there. Hopefully that was helpful. If you have any questions, let me know.